That was just a bit of fun. But my talk today is called Fake It Till You Make It, Python Unit Testing with Mock. My name is Ravi, and this talk has been co-authored by Ben Shaw, so I need to acknowledge him for his contribution. OK, so what are we going to talk about today? Well, first of all, let's talk about testing. I know all developers love testing. It's a favorite tea time topic. So I'm going to talk a little bit about the difference between unit testing and integration testing. Obviously, this talk's going to be focused on unit testing and why it's really cool. So how are we going to deliver this talk? We're going to have an example enterprise application called our Echo server as a motivating example to show how we can use the Python mock library to test complex applications. So the final point is, obviously, we're going to be looking at how we can use mock in practice to test our dummy application. So testing, unit testing versus integration testing. At least when I was a young developer, for me, tests were just tests, and they were boring things that I didn't like to do. But now I've come to appreciate tests. And one of the things that it took me a little while to grasp is the difference between unit tests and integration tests. So I'll just cover that briefly. Unit tests are used to verify small pieces of functionality. So code does what it's supposed to do without involving the bigger picture, the actual application. Whereas on the other hand, integration tests are written to verify the operation of a complete system. So the sum of the parts, if you will. So to put that into a bit of context, I've got a slide which shows kind of the development lifecycle and so on. So in the beginning, we write code and tests. Ideally, we'd write our tests before our code. But sometimes it happens the other way around. And our tests at that stage should be unit tests. So we test only the code we write. And as we go on, we deliver our code to QAs and QA team and so on. And then we run integration tests and to see how the bits of code that we and others, our colleagues, have written fit together and whether it all works as intended in an actual system. And so once that's been verified, it gets deployed and so on, and we test again. So obviously, if we can find bugs as we write code, it's so much faster, easier, and cheaper to make corrections at that point. The further we go in our development lifecycle, the harder it is to address problems and fix code. So that's why unit tests are so important, and it's the focus of this talk. So let's have a look at the rules of unit testing. Number one, you do not test somebody else's code. They've tested it, so therefore it must work. And number two, you do not talk about unit testing. And so in all seriousness, this slide has a bit of merit, because let me explain. First of all, with unit tests, we only want to test code that we write. And so we don't want to test other people's code. So that kind of ties into these two rules, because we want to decouple our code and our tests from those of our colleagues. We should assume that they are geniuses, and they have written tests for the code that they've written, so therefore we should not test it. Makes sense, right? So let's have a look at this in a practical context. Our boss comes to us and asks us to write them an application that reads an input string and then performs one of three operations. Either echoes the input text, echoes the input text reversed, or echoes the MD5 hash digest of the input text. So no sweat, we can knock that up in 5 minutes. And there you go, we've got our command line application delivered to our boss in about 8 lines of code, I think. But if your workplace is anything like mine, that's not enterprisey enough. We need more Dilbert. So how should this actually look? Oops, sorry. OK, so this is our enterprise Echo application architecture. So we've got 3 separate components, an Echo server. So that's an external service. And we talk to that using HTTP with an Echo client. So we can think of that as a Python API or library. And then we have an ECHOVIEW, which could be our Python application that uses the Python ECHOCLIENT library to deliver the actual application code. So to start off, let's have a look at the Echo server. So that is a service, and we want to create 3 endpoints to achieve the functionality that's been asked from us. So number 1, echo, so that prints the string as we get it. Reverse, that reverses the string. And MD5, which returns the MD5 hash digest of our input string. Each takes in a text value via an HTTP post method in the value key. So we can implement such a server quite simply using the Flask library. I've got an example of our Echo server. So this is quite standard Flask code. We've got 3 endpoints defined with root decorators. So I won't go into too much detail over here. Hopefully, you guys are sort of familiar with web development, and this will make sense to you. It's quite simple. We've only got 3 basic lines of code where we return the input value in the echo's case. We return the reversed input value in the reverse case, and obviously the MD5 hash representation for the MD5 function. So we can test this quite easily with some unit tests. So here are our tests for the Echo server. There's nothing fancy about these 3 test cases, and they're not comprehensive tests, but don't worry about that for now. We're just using the standard Python unit test library with the Flask test client helper method to do some basic assertions that our 3 endpoints do what they say they do. So we have some unit tests, and we're geniuses, so the Echo server must work, right? So let's revisit our Echo architecture. So the next stage we want to look at is the Echo client. So that's our Python API that communicates with the Echo server to expose the functions to our application. So the Echo client, we want to have an API with 3 public methods, echo, reverse, and MD5, as we've discussed. And each takes a single argument, a string to operate on, and returns a transformed string. So we can write an Echo client quite easily. And in this case, we're going to use the Python request library to make HTTP calls. So we've defined 3 functions that we want to expose, echo, reverse, and MD5. And they all call the make request helper method. And that method basically uses the request library to make a HTTP post call to our Echo server service. And it gets the response and returns it. So how do we test this? Well, let's remember, first of all, whoever our Echo server is a genius, his or her code works exactly as documented, so we do not want to test it. So what do we need to test? Well, we know the Echo server should work as documented. See rule number 1 of unit testing. So what we need to do is we just need to make sure we call the Echo server correctly, in this case using the HTTP API. So how do we do that? Well, we need to decouple our external service calls from our client library code. And so this is where the Python mock library comes in to help us. Mock to the rescue. So we can use mock to decouple the remote service from our library code. So then we can devise some tests that look a little bit like this. So we're going to test for 4 things: the URL generation, making the actual API calls, our request and response to the external service, and some exception handling. So let's have a look at this in a little bit more detail. First of all, the URL generation. This is all simple Python stuff. So we just want to test that our URL for our external service, the Echo server, is stored and generated correctly. So I'll skip over this. This is quite straightforward. And then we want to test our API calls. So this is basically whether our client library can correctly communicate with the external service. So let's have a look at a test case for this. First of all, the .client variable is our ECHOCLIENT object instance. So on that is a make request method. And so what we want to do in this case is we want to mock that out and decouple it from our test code so that we can actually test its operation. And to do that, we make use of the magic mock object. So let's have a look at our application code again. So that's at the bottom, make request over there. So what we are doing here is we're saying that we want to replace the make request function with a magic mock instance. And so then, when in our test code, we can make an assertion to test whether the make request function is called with certain arguments. So the mock library provides a number of useful assertions that we can use to verify this operation. So we replace that function with magic mock. So our application code then looks like this. Rather than call the make request function, we're actually calling the magic mock instance with certain parameters. So in our test case, we can then assert that the magic mock instance is called with the parameters that we expect it to be called with. So in this case, we're testing that make request is tested with echo as the first argument and echo test as our payload. So that way, we can verify that the echo function does what it says it does. So let's have a review of the magic mock object. So the mock library provides the magic mock class, and we can manually instantiate it as we've done in this case. So magic mock can replace methods or attributes, and when you do not have direct access to what is being accessed. So magic mock is magic. It's callable. It can fake attributes, and it can do so much more. So the really cool thing is magic mock allows us to isolate functionality. So by mocking the entire make request method, we have isolated it from testing our public echo method. This means we can write test cases that are focused on testing small, specific pieces of functionality and not having to test the remote service calls and so on. Moreover, we can extend this technique to mock larger monolithic functions by repeatedly applying this pattern using multiple applications of magic mock. It's awesome. So now that we've verified the echo API function correctly calls make request, we need to verify that make request functions as we intend it to. So make request uses an external library, the Python requests library, to make the actual HTTP post calls to our echo server. So that's not a problem. We can use magic mock again to verify that make request correctly calls request.post. So we have some more test cases over here to test for the request and response functions of make request. So here's our test case for testing the make request call. In this case, we've introduced a new concept, which is the mock patch decorator. So what we're asking for is for mock library to patch request.post method and replace it with a magic mock instance. And that instance is passed in as a parameter to our test case. In this case, I've named it mock request post. So since it's a magic mock instance, we get all the cool assertions that are built into magic mock. So once again, we can use the assert called with function to test that we're calling the correct API URL endpoint with the correct data that we provide in the test case. So our application code looks a bit like that. So we're replacing the request call with a magic mock instance. And so with our assertion, we can be sure that the request call is being called with the correct arguments. And so therefore, we can verify that we're calling our external function correctly. So let's talk a little bit more about the patch decorator. Well, it can help us to mock out stuff that we don't want happening at test time. For example, test a network or disk access or database calls, or basically anything, really. And so the patch classes or objects are passed in as arguments to our test case. And so it's really simple to use. You can just import the patch decorator from the mock library. And I've got a couple of examples at the bottom. And And one thing to keep in mind is when you're stacking decorators, you have to keep the ordering in mind. So in this case, it's actually the first decorator is the last argument passed into your test case. So we can use the same technique to provide return values. So in this case, we want to test that our request.post call returns something useful and to the rest of our application code. So in this case, we're explicitly instantiating a magic mock object. And over here, we're dynamically applying some attributes to that. So we're setting a status code of 200, and we're setting the text attribute to be return value. So that, and now we're using the patch decorator in our test case as in a context manager, and we're setting the return value when we patch request.post to be a new magic mock instance, which is that response object we've just created. So we can use the same, we can make the client call, and so in our data variable is actually now going to be that magic mock response variable instance that we just set up. And so we can assert that the data is what we expect it to be. So if we look at our application code below, our response is now going to be returned as a magic mock instance with the certain attributes that we've set up. So that way we can be sure in our test case that we are testing for the correct attributes that we expect. So magic mock is really versatile in that way, and so you can use it to mock out all kinds of return values with, and you can have mock objects that return other mock objects, and so on. So it's really fun. Another thing we can test for is exception handling. And so how do we do that? Well, when we're in our application code in the make request function, we could actually have an exception occur. So request.post could raise any number of exceptions. And so in our make request function, we actually caught that exception and we re-raised it with a new message. So how can we actually catch those and test for those exceptions? Well, the mock library makes it really easy for us to test that, and it's something that traditionally is actually quite hard to do. How do you fake an exception? Well, it's quite easy with mock because we can use the side effect function to raise an exception. And side effect can also be used to actually return values. And you can actually set a side effect to be an iterable, and we can chain request calls with that. But in this case, once again, test cases can now be isolated just to test exception cases. So let's have a look at our actual test case. So once again, we're testing for an exception, and we're going to use the patch decorator to mock out request.post. And so we're setting a side effect here called HTTP error. And so what happens is that whenever that magic mock instance is called, it's going to raise the HTTP error as a side effect rather than doing any processing or so on. So, so we can see our application code below. So response is once again going to point to a magic mock instance, and we're going to catch that request exception. So in our test case, the magic mock object, once it's called, it's going to trigger that side effect and raise that HTTP error, which in our application code will raise an ECHOCLIENT error. And in our test case, we're going to catch that ECHOCLIENT error and verify that it's as we expect. So that is, it's an HTTP error with the message of ECH. So with these test cases in place, then we can probably say that the ECHOCLIENT must work. So now, going back to our architecture, the final component is going to be our actual Echo application, so the user visible interface. So let's have a look at how we can rewrite that to this time use the ECHOCLIENT API library that we've just developed. So once again, this is pretty simple. So over here, the second line, you can see we've imported our ECHOCLIENT library, and we've got a very simple ECHOView class, which uses the client to call the three methods we've defined: echo, reverse, and MD5. And below that, we've got a helper method called processEchoCommand. And this is just for a bit of fun, and it will dynamically dispatch our command using the Python get attribute function to look up the appropriate function to call at runtime based on the string passed into it. So, so that's cool. How do we test this? Well, let's remember our rules of unit testing. Whoever wrote the ECHOCLIENT is a genius. Her code must work exactly as documented. So we don't want to test the ECHOCLIENT. We want to decouple it from our test cases. So what do we need to test? Well, yeah, we know that the ECHOCLIENT works as documented. That's cool. So we just need to make sure that ECHOCLIENT is called correctly. So once again, we've got some test cases. So we're testing our 3 endpoints. And in this case, we also need to test our process echo command, our dynamic dispatch function. So our 3 endpoint functions are quite similar, and I won't go into that. It's quite similar to what we've already done. But the interesting thing is, how do we actually call the right function based on a string? Well, we're using the Python get attribute function to take in the command as a string and then look up into the ECHOView instance and find the right attribute, in this case the function, to call. So this becomes a little bit trickier to test for using Magic Mock because we can't directly mock out the __ get attr method, which is a magic method in Python to do dynamic lookups. Unfortunately, with the mock library, you can mock out a lot of the magic methods, but this is one that you can't because there's a lot of magic going on in the background. So yeah, so this is the challenge, to dynamically find the appropriate function to call using mock. So how can we do that instead? So what I've presented in this slide is a little bit of a workaround in this case, instead of directly trying to test that, say, for instance, we are calling echo and we call the echo method, instead I add a new function to our ECHOView object class, and then I test that that's called. So since the new function I add is a Magic Mock instance, I can then use Magic Mock's assertion methods to test that it's called. So let me just walk through the slide a bit. So on the, first of all, we've got our test case, and we're patching the ECHOView object as a mock class. And so what we do is we actually set the return value to be a Magic Mock object. And so we create a new Magic Mock instance explicitly called mock_foo in this case, and then we attach it with the .foo attribute to the mock object class. So then when we call process echo command, if we call it with foo as a string, we can then test the mock_foo object was called correctly with the arguments that we expect. So this is a bit of a workaround, but it's quite easy to apply in practice and allows us to test for this magic method. So now that we've tested ECHOView, it must work. So therefore, our Echo enterprise architecture must work. Well, not quite. We've only tested some happy path cases. And so definitely, this is just an example to show you how you can use the mock library. But obviously, at this point is where you could come into using integration tests and so on to test your application works as a whole. So to conclude, what have we learned? Well, unit tests should be small, and they should test isolated pieces of code that you write and not what other people write. So they should execute fast and not rely on other components. So for instance, a lot of you might be using Django, for instance, as a web framework. And I know initially, when I used to write test cases for Django, I would always set up the database and test things using that. But the point of using the mock library is to try and decouple your code from external services like a database and test just the functionality. So we should rely on the assumption that external code and services work as advertised. Don't retest them. For instance, if you're developing a Twitter client that makes use of the Twitter API, well, the point with using mock, you don't want to test that the Twitter API works as intended. Obviously, well, hopefully, they would have tested that, and so therefore, it should work. So you just want to test that you are using the Twitter API as it should be intended. So the mock library provides a mechanism to decouple application logic with external services. Definitely use it. So finally, the Python mock library. Thank you, Michael. It is an exceptional library, and yeah, you can use it to patch classes, attributes, and so on. There's numerous built-in assertion methods. I've only used the assert calls with in this demo. It's just scratching the surface. There's a website, or you can fire up Bing and search for Python mock. It's a third hit, so definitely go check it out. Thank you, and enjoy testing. Cheers.